Welcome to Shrinkage Part 2. Last time we talked about the anomaly of a vertical whip seeming too short in some circumstances, and this time we'll talk about the solutions. Welcome to yet another ham radio video. This is Jay, KQ4DUX. Thanks for joining me. Last time when we talked about the vertical whip shrinkage anomaly, we set it up in several different locations and several different deployment methods, and we got different results with different whips and different deployments. I did a lot of demonstration and taking readings on the antenna analyzer. And at the very end, we talked about some of the things that affected our results and what we might do to solve this problem. So I have done a lot of testing and trying different things to come up with a solution. So I've got some of those for you today. And number one is checking all your connections. So I would start, you could start at the radio, so including your coax. What if your coax is damaged, or there's, for some reason, the connections on either end of that is not making a good connection? That could possibly cause some erratic results and cause some things to change. The next thing that I looked at in my situation was the antenna mount. So on the mount on the van, which I have used quite a bit, there are 4 screws holding it to the body of the van, and then there's a flat plate, and then there's the SO239 to 3/8 fine thread nut. So I did check the screws, and I did swap out the adapter that the whip screws into one end and the coax to the other, because those things can fail. A lot of these things I'm talking about today, maybe not very likely, but they are things that you should check. Another thing, if you're using a vehicle mount, you may want to look at the bonding of your body panels together. So fortunately for me, I'll just step up here. I'm right next to the van now. As you can see, the ground plane is pretty much one big flat rectangular space, whereas if you had something like a sedan where you have the roof on top of the car and a fairly sizable hood and trunk lid, those are separate things, and they operate on hinges and different things like that. That could cause those metal objects to sometimes connect to the antenna and sometimes not, which could offer those bad results that we're talking about. So the term here is bonding. A lot of people will take short pieces of like a stainless braided cable or copper too, or whatever material you want, something that's a good conductor and that's gonna hold up to the environment, and bonding those individual body panels together. So for me, I didn't really feel that was necessary, because like I said, we had that big giant ground plane on top, and I have just this little bitty hood right here. So I don't really think that really was the issue. The next thing to take a look at is your radios or whatever type of counterpoise system. How is that being connected to the antenna? Let's take a look. And I did find one thing that I repaired, but something like this. I've got the bucket mount, and I've just got these automotive type ring connectors here, but especially this speaker wire, over time, they may break. I probably could have done a better job at putting these together and put some heat shrink or something like that would probably increase the lifespan, but enough of moving back and forth like this, eventually these wires will fatigue and let's just say it was 16 strands to begin with. Say you lose 4 or 5, you get the picture. That could change things. So one thing I did was cut it off. And then moisture inundation is another thing. If you get moisture in there corroding it, another thing to check. Now, depending on your situation and how you're mounting it, so especially with ground mounted, you may need to add radials. So sometimes your soil is less conductive or has different permeability than other places in the location. So you may need to add, you may need to lengthen, or if you're running a tuned radial that's cut for a specific band, you may need to adjust that. The next thing you can do, which I did mention in the last video, was just move your vehicle, or if you're not in a vehicle and you're set up in a park, just moving a few feet. Maybe go to a different park bench, or you know, closer to or farther away from a tree or a building or something like that. I've even found many times using like the POTA Performer type that it may tune well with 1 but not with 2. It may tune well at a 90 degree with 2, or it won't, and then you move it to 180. A lot of times I just run a single one, and just say I have it facing this direction, I'm at whatever 1.7, and I move it over here and now I'm 1.4. So all those things can make a difference. The next one, and I did mention this in the last video as well, is to take a look at or swap out your choke and your coax too. Maybe a different length of coax may make a difference, but especially the choke, for some reason we usually think of them as pretty passive in the whole system, but again, I have seen fairly significant changes with a different type of chokes. Now, the 2 chokes that I use frequently are good quality, and you know, they're not cheap. I use the ABR Industries coax with their ferrite bead chokes that they install, and I also use the Palomar Engineers line isolator. And you know, neither of them is not because they're inexpensive or whatever, they work a little bit differently. They're going to have some different characteristics, and again, I have seen that make a difference from above 1.5. say I'm stuck in that 1.6 or 7, and I get down to 1.3 or 4. And the next one I will mention, which really was a great solution for me, is a capacitance hat. Now, it has been called a capacitance hat, a capacitive hat, a capacity hat. I'm not going to argue over which is right or what. That's for a different video, but we're all talking about the same thing. Basically, we're adding metal, conductive metal, somewhere on our antenna, preferably at the top. They are going to be the best at the top. So it'll do a few things. It does electrically lengthen if we have other things in the environment that have caused it to be electrically too short. From what I've read, and you know, I understand it basically, maybe not perfectly, but it changes the current distribution and puts more of the current up higher, which should increase your bandwidth, and it should electrically lengthen and bring your resonance lower. One thing you do not want to do is install this very close to the bottom or to the feed point, which can actually reduce your efficiency. So let's take a look at a couple different ones. These are all homebrew builds that I made. And if you're interested in building one, I am working on a video of how to build it, because it just, again, it would get too long to go through the whole steps. So I'm just going to mention a couple different types. So this type is just kind of like the cloverleaf type. You've probably seen these. I know that Chameleon does sell them, but for some reason they're out of stock and have been for a little while. So that, I mean, it looks similar to this, only it has a machined hub. And again, this was like a 10-minute what do I got laying around type of project. So all I really did was solder these copper wires and kind of just bent it into the cloverleaf shape. The hole in here is maybe a little bit too big. I like to have it ride up a little higher if I could. So this did make a difference. It wasn't as much as I would have liked, probably due to being fairly low on the antenna. So the next one I made looks like this. So this one's designed to go on the very top of the antenna, and this is just a basic cross circle with a circular one. So what I did to make this was I formed it around a 5-gallon bucket, put in the cross pieces, and then have a piece going down. And I also made a little bit smaller one. This was version 2.0, just a little bit smaller, because one of the things you've got to remember with this is you're adding weight, and you're also adding wind load way up at the top. So this is gonna, if it's not balanced correctly when you build it, try to get it as balanced as you can. I'll just demonstrate that real quick. But if I hold it, I'll try to do this while I'm holding the camera. But if I hold it and spin it slowly, if it's way out of balance, it will want to obviously stop where the heaviest part is. So the slower that it turns before stopping, the better. And it's not maybe perfectly balanced, but it's fairly close. Just one thing to keep in mind, but all those details will be on the how to build video. So let's talk about attaching this. Somehow we have to attach this to here. What I went with was, this is a 1/4-inch piece of gas line. So I bought this from an auto parts store, and it came in a 1 or 2 foot section, and it's rubber, but it's pretty stiff, and it's a 1/4-inch, and this antenna ends up being very close to a 1/4-inch. So this is a very snug fit on this one, probably because it's so stiff. And then below it I have just an O-ring. So this is just a rubber O-ring. Again, a 1/4-inch, bought it at the hardware store. So what has worked for me is the O-ring will hold kind of the bottom part against the antenna, so we have more than one attachment point. And the top, I put it together like this and just slide it over the end. And again, that is a pretty snug fit, but there it is. It holds on there. You can turn it, but it's not going to be freewheeling in the wind. And then, I don't know if you can see this, but it's not quite straight, and this copper is very flexible, malleable, and it's supposed to be. But just another thing to keep in mind, they are fairly fragile pieces, and I used a torch this side of this, but again, we will get to all those details in the how-to video. Alright, so I've got the whip put up, it's fully extended, and one other little tip, know how many sections there are. On this one, I believe it's 9, and every time I pull it out very slowly and deliberately, and I count each section, make sure it's all the way out, so you eliminate that possibility. And this is usable like it is. It's 1.5 at the bottom of the band, but if we look at the sweep of the band, our lowest is at 14.5, so out of the band, similar to what we were seeing before. Like I said, I know it's usable, but let's see what these capacitance had and any other things we might do, how that would change things. So now with the capacitance hat, I am at 1.41 at 1385. So that took us from way above the band to below. So I may be able to adjust this and get it to where I want, but sometimes there's something else that will do the trick. Okay, now we've got it down 1.1, at 14.24. And let's take a look down in CW right at the bottom of the band, 1.27. So what did I do? I added a single wire. So this is a radio that's cut for 20 meters. And again, like I talked about before, somewhere between here and over here I even had 1.07 or something, but I moved it over to, say, right here was 1.3, 1.4. I took the ladder. What about if we go more straight perpendicular to the van, and again 1.3 or 1.4. Well, a lot of people would say, well, that's just splitting hairs, don't worry about 1.3 and 1.1. And I mean, really, nobody's going to know the difference. It's once you get to that level, it's a very minuscule difference in performance. But I still think it is important to know, if you want to understand how all of this works, to experiment and know what changes things, because sometimes you might be in a situation where, you know, you just can't get to where you need to be, and maybe you have to make a combination of things and get it, add them up and get it to where you need to be so you can operate. And even it may not be a matter of efficiency of 1.6 or 7 to 1 versus 1.2, but you're losing it in heat. Maybe you have a rig that tends to run hot and you don't want to be losing, you know, putting more heat and more stress on that stuff. To me, that's a little more important than the tiny bit of efficiency that you gain. But on the other hand, we always want to do the best that we can. Another thing to mention was the size of the hat. So let's take a look up there. Hopefully y'all can see it. So that is the smaller one of the two, and this is the larger one. So obviously the more surface area and the more metal we have up there, the greater effect it's going to have. So I used the longer one. If you recall from the last video, I was using the bucket for 40 meters and I was way on top of the band. I don't remember what the SWR was, but not as low as I would like, and I used the bigger one for that. I've been using the smaller one for the 17-foot whip. Well, thanks for coming along. I hope you learned something. I know I sure did. Some of those problems were pretty frustrating, and it did take me a lot of experimenting and some time, but I feel a lot more confident now with bringing these capacitance hats with me, that even if I run into that situation, I'll be able to make it work. Now, one thing I want to say before we get out of here, I don't do a whole lot of promoting the channel. You know, I may put up a graphic, like and subscribe, but I just haven't pushed that very hard because, you know, I think the information should stand on its own. But I have to say the views and the performance of the last several videos has fallen off quite a bit, and part of that is just because when people don't like and comment and share and all that stuff, YouTube doesn't recommend it as much as they do with a video that gets a lot of that. So if you found this helpful, again, like, subscribe, and all that stuff. And stay tuned for the build, how to build the capacitance hat. That should be coming up very soon. So if you're seeing this close to the release date, that should be out within a few days. If you're watching it later on down the road, it should be up there on the channel. So this has been yet another ham radio video. This is Jay, KQ4DUX. Thanks for coming along. Take care. 7-3.